I want you to consider the most unusual thing you are aware of in the cosmos. Maybe you're picturing a black hole or pulsar, or even a strange binary system consisting of a black hole and a pulsar that was produced by mysterious physical rules and forces. We have evidence that each of these things exists in our universe. For instance, we are aware that the Milky Way's core contains a black hole directly in its center. Here is an image of the black hole M87 event plus S horizon in the M87 galaxy. Before we had even seen one, such objects were prophesied to exist. Before the Event Horizon Telescope showed us M87 event plus S horizon, we had never seen a black hole, but we intuitively knew that we will be able to view one eventually since math tells us that black holes exist. In actuality, the general relativity theory leads to the existence of black holes. It's not the only one though. For instance, we are aware of the possibility of an object existing that defies the laws of time and connects two different universes or portions of the universe. Though, wormholes are the name given to them. Follow me in this video to learn more about them. Wormholes were originally theorized in 1916, though they weren't known by that name at the time. Ludwig Flamm, an Austrian physicist, was responsible for solving Einstein's equations for the general relativity theory. In contrast to the well-known solution of a black hole, he named the resulting mathematical entity a white hole. What we understood was that a particle could theoretically enter a black hole, and that once inside, there was no way out because the laws of physics changed inside the black hole, and all the particle could experience was an infinite fall toward the center of this monstrous object, also known as a singularity. Yet, Flamm actually discovered that a kind of space-time conduit might connect the entrances to both black and white holes. As a result, researchers worked hard on the issue, and in 1935 Einstein and Rosen attempted to utilize general relativity to demonstrate that such bridges crossing spacetime might exist. They proposed that such bridges may link two separate places in the spacetime grid by passing between a white hole and a black hole. They could shorten their journey's duration and distance, and that was all this meant. Wormholes or Einstein-Rosen bridges are the names given to these bridges and shortcuts. Yet, as is nearly often the case, we must make a distinction between mathematical and physical results. The first two can happen at any time and result in mathematical objects. The notion that mathematical objects are also physical ones isn't always true, though. That is the exact boundary between physics and mathematics. The first suggests that there might be something. The other's responsibility is to determine whether the answers are real in the sense that they really do exist in the cosmos. Given current technology, we tend to conclude that something doesn't exist if we can't see it. Probably suggests that we must always keep in mind the limitations of both our technology and our observations. However, that's the whole thing. According to scientists, wormholes are currently only speculative, and no one believes we will discover one anytime soon. Let's nevertheless gain a better understanding of how a wormhole should be created. In theory, a wormhole can be thought of as a bizarre creature with two mouths and a throat linking them. The throat may be straight or it could wind around, taking a longer travel than a more traditional approach could require. The mouths would most likely be spheroidal. Einstein's theory of general relativity, as we've already mentioned, mathematically predicts the existence of wormholes, yet none have been seen thus far. Even while we don't really know what is needed, something else is undoubtedly necessary. One of the two mouths may likely be a black hole. Could a naturally existing black hole, created by the collision of a dying star, always produce a wormhole on its own? Perhaps more is required. You have undoubtedly previously heard of wormholes if you enjoy science fiction films. They are accustomed to traveling through spacetime, and they appear to be fairly simple to operate. Yet, the reality of these journeys is more nuanced. First off, if we ever discover a wormhole, which we haven't done yet, we would discover that it is somewhere between 10 and 33 centimeters in size. This is a serious issue. But given that the cosmos is enlarging, it's possible that some of them have grown in size. Stability is the second significant issue. Wormholes would really be very worthless for travel, according to Einstein and Rosen's theories, and this is because they collapse so quickly. Hence, when we state that a wormhole is unstable, we really just mean that it is unstable. Yet, this issue might be resolved if exotic matter, distinct from dark matter and antimatter, exists. In fact, according to physicists, a wormhole filled with exotic material may continue to be open and unchanged for longer periods of time. A more solid wormhole like that one would enable us to enter its throat. Whether or not this unusual substance exists is unknown to us, but if it did, it would have a significant negative pressure and energy density. No known object satisfies these conditions. Only in the behavior of specific vacuum states has such matter been observed, according to quantum field theory. It's possible that the addition of ordinary matter might be enough to destabilize a wormhole, even as adding exotic matter could stabilize it to the point that human passengers may pass through it without danger. We don't now have the technology to stabilize or expand wormholes. But, in the hopes that technology will one day be able to use them, scientists are still researching the idea as a means of space travel. Moreover, a wormhole might hypothetically be utilized to convey information or travelers through space if it contained enough exotic matter, whether naturally occurring or purposefully supplied. The good news regarding wormholes is that, after around 10 years of diligent research, we still cannot demonstrate their non-existence. However, this wouldn't be over because it might be difficult for humans to go through the space tunnels. You must have a deep curiosity about human spaceflight and the secrets of the cosmos if you are here watching this video, so subscribe right away and make sure to turn on the bell notification so you never miss out on the latest information about the cosmos. One of the foremost authorities on general relativity, scientist Kip Thorne, stated that there are extremely strong indicators that wormholes that a person may travel through are prohibited by the laws of physics. That's bad and depressing, but that's the way things are going. Now, putting the unfortunate events aside, perhaps it would be best if we concentrated just on a description of a wormhole. For instance, researchers discovered that wormholes might link not only two distinct cosmological regions, but potentially two distinct worlds. To sum up, we know that 1. Wormholes may exist, but we have never seen one. 2. They are quite little, measuring between 10 to 33 centimeters. 3. They are incredibly unsteady. 4. They might permit shrinking the distances of space-time inside the same universe. 5. They were able to link two realities. 6. Despite the fact that we have never seen one, there is still no reason to believe they don't exist. Wormholes' potential use in allowing time travel is one of their more intriguing possibilities. This is how it goes. First, create a wormhole, then take a spaceship and one end of the wormhole, attach it to it, and travel at a considerable fraction of the speed of light. The time dilation effect would occur in this manner. Only a few years will have passed for those aboard the spaceship, yet it may have been hundreds or even thousands of years for those on Earth. If you moved in a particular direction, you would not only travel the distance between the wormholes, but also be taken to the moment that the wormhole is currently experiencing. Going one way will advance time, going the other way will move time backward. This would go against two of physics' most fundamental rules, local energy conservation and the energy-time uncertainty principle, thus physicists believe it wouldn't work. Another worth mentioning is that recent research on quantum teleportation, which is the disembodied transfer of quantum information from one place to another, has revealed that it functions similarly to a wormhole connecting two black holes. The quantum information dilemma, which holds that physical information might completely vanish in a black hole, appears to be resolved by these tests. Yet they also reveal a deep relationship between the supposedly irreconcilable theories of quantum physics and gravity, with wormholes being important to both, which may be instrumental in the building of a theory of everything. It is likely that wormholes' significance in these exciting discoveries will be noted. They might not have been visible to us, yet they could still be present. These might even aid in our understanding of some of the greatest cosmic enigmas, such as whether our universe is unique. Here's where the video ends. Thank you everybody for watching. Do you believe wormholes are real? How might you employ them? Please share your thoughts in the comments section below. Don't forget to subscribe, and I'll see you on the channel again soon.